When a star as massive as Jupiter breaks free from its expected course, Betelgeuse, one of the most luminous stars in our night sky, undergoes a baffling transformation that has astronomers both intrigued and thrilled. Picture a star so immense that it would overshadow our Sun and swallow all planets up to Jupiter if placed at the heart of our solar system. This colossal entity is Betelgeuse, a red supergiant in the Orion constellation. For centuries, it has fascinated skywatchers with its deep reddish glow and staggering size. But now, this cosmic titan is acting unpredictably, keeping astronomers on high alert. In an astonishing turn of events, Betelgeuse has recently brightened dramatically, increasing in luminosity by over 50% and jumping from the 10th to the 7th brightest star in the night sky. This dramatic change has left scientists baffled and eager to unravel the mystery behind Betelgeuse's transformation. What could be causing this remarkable behavior? Is Betelgeuse on the brink of a cataclysmic event, or is this just a temporary phase in the star's life cycle? To understand the significance of Betelgeuse's strange conduct, we must delve into the factors that contribute to a star's brightness. A star's luminosity is determined by its size, temperature, and distance from Earth. Betelgeuse is a true giant among stars, with a radius more than 700 times that of our Sun. Despite its enormous size, Betelgeuse is relatively cool for a star, with surface temperatures ranging between 3,000 and 3,500 Kelvin, which gives it its distinctive red color. Throughout history, ancient civilizations have been fascinated by Betelgeuse and have woven the star into their mythologies and folklore. The ancient Egyptians associated Betelgeuse with Osiris, the god of the underworld, while the Greeks linked it to the legendary hero Orion. These myths highlight the lasting mystique of this remarkable star. As astronomers continue to study Betelgeuse's unpredictable behavior, they are left with pressing questions about its fate. The implications are immense, and the potential outcome could be truly astronomical. If Betelgeuse is indeed approaching a supernova explosion, it would be a once-in-a-lifetime spectacle, lighting up the night sky like never before. The blast would be so intense that it could even be visible during the day, casting shadows on Earth and offering an unparalleled chance for scientific exploration. But the big question remains: is this the quiet before a cosmic storm, or merely a fleeting anomaly in the life of a stellar giant? To answer this, it's crucial to grasp the star's vast size and its current stage in the stellar life cycle. Betelgeuse is a red supergiant, an aging star nearing the end of its existence. Like living beings, stars are born, evolve, and ultimately meet their demise. They begin their lives in nebulae, vast clouds of gas and dust where gravity pulls material together to form protostars. As these protostars gain mass and temperature, nuclear fusion ignites in their cores, marking the birth of a new star. Over millions or billions of years, stars like Betelgeuse burn through their nuclear fuel, fusing hydrogen into helium and then helium into heavier elements. As they age, the internal dynamics of these stars change, leading to a series of transformations. When a star with a mass similar to Betelgeuse exhausts, as a massive star depletes its fuel, it expands dramatically, transforming into a red supergiant. At this stage, its outer layers are loosely bound by gravity, making the star highly unstable. A red supergiant like Betelgeuse will ultimately succumb to its own immense gravity, collapsing and triggering a spectacular explosion known as a supernova. Supernovae rank among the most energetic and brilliant events in the universe, releasing vast amounts of energy in a brief span. Betelgeuse is expected to undergo a Type II supernova, which occurs when a massive star can no longer sustain its own weight after exhausting its nuclear fuel. The core collapses, setting off a powerful shock wave that rips the star apart, propelling its outer layers into space at astonishing speeds. If Betelgeuse were to explode, it would be an unparalleled cosmic spectacle. The first sign of the impending explosion would be a massive flood of neutrinos, elusive subatomic particles that rarely interact with matter. These neutrinos would escape the star's core moments before the shock wave, arriving at Earth hours before the light from the supernova. Observatories around the world would be crucial in detecting this neutrino burst, alerting astronomers to the imminent supernova. As the shock wave reaches Betelgeuse's surface and the star explodes, an enormous amount of energy would be released in the form of light, heat, and other radiation. The supernova would quickly brighten, becoming visible to the naked eye on Earth even during the day. At its peak, the exploding star could outshine the full moon, casting shadows and turning night into day for several weeks. Astronomers are buzzing with excitement over the possibility of Betelgeuse going supernova. Dr. Emily Thompson from the University of California, Berkeley, describes it as a ticking time bomb, emphasizing the rare opportunity to witness its final stages. A supernova of this scale would be a once-in-a-lifetime spectacle, offering invaluable insights into stellar evolution, nuclear physics, and the universe's chemical enrichment. However, in late 2019, Betelgeuse took an unexpected turn, dimming rather than continuing its anticipated brightening. This dimming was so significant that it was noticeable even to the naked eye, with Betelgeuse fading to about 40% of its usual brightness. The astronomical community was puzzled by this sudden change and scrambled to observe the star more closely, hoping to unravel the cause behind its fading light. The dimming of Betelgeuse poses a fascinating challenge for astronomers. Is this a sign of an impending supernova, or is there another explanation for the star's unusual behavior? The mystery deepens as we consider the possibilities, and anticipation builds as we await further observations and data. The story of Betelgeuse is far from over. The fate of this mysterious star holds crucial insights into the nature of the universe and our place within it. Betelgeuse continues to intrigue astronomers, as its unpredictable behavior fuels new theories and observations. Defying expectations, the red supergiant keeps scientists racing to solve its mysteries before the cosmic drama reaches its peak. In late 2019, astronomers were astonished when Betelgeuse, one of the brightest stars in the night sky, began to dim unexpectedly. A celestial fixture for centuries, it was now fading before their eyes. Theories emerged, ranging from dust obscuring our view to a massive surface upheaval. Yet the true cause remained uncertain. As the dimming persisted, astronomers focused their telescopes on Betelgeuse, eager to gather clues that could unlock the mystery. The Very Large Telescope VLT, in Chile, one of the most advanced observatories in the world, managed to capture a series of images that would prove crucial in understanding the star's behavior. The VLT images revealed that Betelgeuse's appearance was far from symmetric. The star, which had once appeared as a uniform disk, now had a distinctly lopsided shape. It was as if a cosmic hand had reached out and squashed the star, leaving it misshapen and distorted. But the asymmetry was just the beginning. As astronomers analyzed the data, they discovered the presence of a huge shock in our line of sight. This shock, which was unlike anything they had seen before, seemed to be emanating from the star's surface, suggesting that something truly extraordinary was happening on Betelgeuse. To grasp the importance of these findings, we must first explore the concept of a photosphere. A star's photosphere is essentially its visible surface, the layer from which light is emitted into space. Astronomers had long believed that Betelgeuse's photosphere remained relatively stable, experiencing only minor variations over time. However, images from the VLT painted a different picture. They showed that Betelgeuse's photosphere had begun expanding, making the star appear larger than ever. It was as if the star were gradually inflating like a cosmic balloon, driven by an unseen force. As astronomers raced to make sense of these observations, they discovered two more anomalies that would shed light on the star's behavior. In mid-November 2019, just as Betelgeuse was reaching the peak of its dimming event, astronomers were on high alert. trying to determine whether this marked the beginning of the long-anticipated supernova, or if there was another explanation behind the star's unusual changes. Astronomers observed a dark patch on the southern hemisphere of Betelgeuse's surface. This area, which was once as bright as the rest of the star, had grown noticeably dimmer, indicating a significant change in the star's appearance. Concurrently, a substantial decrease in the star's surface temperature was detected. Typically burning at around 3,500 degrees Celsius, 6,332 degrees Fahrenheit, Betelgeuse had cooled by several hundred degrees within a few months. Such a rapid temperature drop is highly unusual for a star like Betelgeuse, implying that a sudden, dramatic event occurred on its surface. To grasp why this temperature shift is so peculiar, it's important to consider the nature of red supergiant stars like Betelgeuse. These giants are nearing the end of their life cycle, having exhausted the hydrogen fuel in their cores and shifted to fusing heavier elements. As a result, they have expanded to enormous sizes, with radii that can be hundreds or even thousands of times larger than our Sun. Despite their gigantic size, red supergiants are actually cooler than smaller, younger stars like our Sun. This is because their expanded atmospheres allow more of their energy to escape into space, leading to lower surface temperatures. However, these temperature changes typically occur very slowly, over timescales of years or even decades. The fact that Betelgeuse's temperature dropped so quickly and by such a significant amount is therefore highly unusual. It suggests that some kind of major upheaval occurred on the star's surface, one that disrupted its normal temperature regulation mechanisms. As the evidence mounted, astronomers began to converge on a shocking conclusion. Betelgeuse had likely experienced a massive surface mass ejection, SMME. SMMEs are powerful eruptions that occur when a star ejects a significant portion of its mass into space. Though SMMEs had been theorized for decades, no one had ever observed one directly on a star like Betelgeuse. The discovery was nothing short of groundbreaking. If Betelgeuse had indeed undergone an SMME, it would suggest the star was even more unstable than previously believed. This raised concerns about the star's future and whether it was nearing the end of its life. However, the SMME also presented a unique opportunity for astronomers. Studying this rare event in real time could offer unprecedented insights into the inner workings of massive stars and the processes that drive their evolution. It was a rare chance to witness the cosmic spectacle of stellar death and rebirth, to observe how the universe recycles itself on a grand scale. Could Betelgeuse's dimming be just the beginning of an even greater mystery? The massive surface mass ejection SMME that Betelgeuse experienced could be compared to a star-sized volcanic eruption. Picture a celestial giant, so enormous it makes our Sun seem tiny, suddenly releasing an immense amount of material from its surface. Using complex algorithms and powerful supercomputers, researchers created detailed models of the star's interior, simulating the intricate physical processes that govern its behavior. These simulations revealed that an unusually hot current of gas, like a massive searing bubble, rose from deep within Betelgeuse and burst through its surface, triggering the ejection of material. The simulations employed by astronomers are marvels of modern science. They incorporate a wide range of variables and parameters, from the star's temperature and density to its magnetic field and rotation rate. By feeding in data from state-of-the-art telescopes like the Very Large Telescope VLT and the Hubble Space Telescope, scientists can create a virtual replica of Betelgeuse, a digital twin that allows them to study the star in unprecedented detail. With these simulations, astronomers can explore the possible causes and consequences of Betelgeuse's SMME and pulsation changes. Astronomers can simulate the evolution of stars over millions of years, watching them grow, transform, and eventually meet their end in a spectacular cosmic explosion. These simulations offer a unique window into the star's core, revealing the intricate and often unexpected processes that shape the universe around us. As the countdown to Betelgeuse's inevitable supernova continues, what advanced technologies and innovative methods are astronomers using to uncover the star's secrets before it's too late?